Now let's just move on further towards a new concept in the surface area and the volume, which is nothing but called as the frustum of a cone. What is the frustum of the cone? So let us suppose if I am just taking a particular cone and I have a plane, and I am just taking the cone and the plane in such a manner such that the cone is actually sliced by a plane parallel to a base. So as you can see over here, so let us suppose if I'm just taking this particular cone and I'm taking this particular plane such that the cone is actually sliced by this particular plane which is parallel to the base of this particular cone. So let us suppose if it is actually just slicing out the cone, so we can say that if I'll separate the two portions, then these two portions should be of this form. As you can see over here, the two parts which are separated over here is nothing but this one and this one. So these are the two parts. So what is the frustum in both of these? So as you can see over here, the second part that we are getting is nothing but called as the frustum of a cone. This is nothing but called as the frustum of the cone. And now we will deal with the frustum of the cone and we will find out the volume of it, the CSA of it, and so goes on. So this is nothing but called as the frustum of a cone. It is again a part of a cone. So this is called as the frustum of a cone. So let's just generate a formula for the volume of the frustum of cone and for many such other things. So let us suppose if we are just starting with the taking h be the height of that frustum, l be the slant height, r1, r2 be the radii of the ends of the frustum, where r1 is nothing but greater than the r2, means r1 should be the base radius of the frustum and r2 is nothing but the upper radius of the frustum. Now the volume of the frustum of the cone is actually nothing but pi by 3h into r1 square plus r2 square plus r1 r2. This is nothing but the volume of the frustum of a cone. And if I am talking about the CSA of the frustum of the cone, it is nothing but pi into r1 plus r2 into l, where l is nothing but h square plus r1 minus r2 whole square. This is nothing but the slant height of the frustum, that is L. Now further, if I am just talking about the TSA of the frustum of a cone, so this is nothing but pi L r1 plus r2 plus pi r1 square plus pi r2 square, where L is nothing but the square root of h square plus r1 square minus r2 whole square. So let us suppose if I am just forming a frustum over here. So as per this, so let us suppose if this is my frustum that I am taking. This is the frustum that I am taking over here. So if this is the frustum, then you can see I'm just taking this radius and this radius as nothing but, let us suppose if I'm just writing it as nothing but this is my R2, this is my R2, and this is nothing but my R1. So you can see all by yourself that R1 is definitely greater than that of R2, and this is nothing but the height of this is nothing but the height of the height h of this frustum. This is nothing but the slant height of the frustum, that is L. So there is a relationship in between L, H and R1, R2 that you can see over here, that L is actually nothing but is equal to square root of H square plus R1 minus R2 whole square. This is nothing but a relationship in between the slant height, the height and the radius of the two ends of the frustum. So this is all about the volume of the frustum, the CSA of the frustum of a cone and the TSA of the frustum of the cone. So let's just do some of the questions that are related with it.